Welcome to lesson 1.3 where once again we're doing more limits. So these limits are special limits. They're limits at infinity, which we kind of introduced in 1.2. So let's look at this as an example. So a little review. This graph, if we notice, that has a factor on top and on bottom, which is going to cancel out. So it's going to have a hole at x equals 1. Because the factors canceled, there's a hole there. Then we also have what are called even asymptotes and odd asymptotes. Now, even is told by the degree on the asymptote. Asymptotes are always in the denominator. So we're going to have an even asymptote at x equals 2 and an odd asymptote at x equals 4. Now, to go over what that means, even means they're pointing in the same direction, either both up to infinity or both down to infinity. Odd means they're pointing in opposite directions. So if we talk about limits at infinity, let's start by doing a couple examples. When we do limits at infinity, you need sign lines. Now, hopefully you remember these from Secondary Math 3. So first off, I look at this first limit. It's from limit of 2 from the right. So this limit, particular limit, I only care about from the right. Now I know if I plug 2 in, this is an asymptote. So this is going to be vertical asymptote at x equals 2, and the exponent on it is a 1. So I know this is an odd vertical asymptote, which means it's going to look like that or like that. They're going to go in opposite directions though because it's odd. So what I need to do is figure out what the sign is for here, because if it's a positive number, then I'm going to have that option. If this is a negative number, then I'm going to have that option, down to negative infinity. So to find the sign, I'm just going to pick any number that is greater than 2, because I'm looking at the right-hand side of 2. So let's just pick 3. And if I pick 3, so I get 3 plus 3 over 3 minus 2. 3 plus 3 is a positive. I don't even really care what the number is, just the sign. 3 minus 2 is still a positive. And a positive divided by a positive is a positive. So that means the limit as we get closer and closer to 2 is going to go up to positive infinity. Now let's look at it as we do 2 from the left. Now, I know that this is odd. I also know that this one went up to positive infinity. So I don't actually even need a sign line because I know this is odd and this is the same function. Then I know this one is going to have to be negative because they go opposite directions since they're odd. So this one is going to have to be negative infinity. Let's try this one. This one I'm going limit as x goes to 1 from the right, positive, and I know that this is a even vertical asymptote at x equals 1. So that means they're both going to go up or they're both going to go down. I want to go from the right, so I'm just going to pick any number to the right. Let's say 2. So 2 minus 2 over 2 minus 1 squared. We ran into a problem. That's 0. 0 is neither positive nor negative, so that doesn't really help me. So let's pick one even closer to 1. Let's try 1.5. So I have 1.5 minus 2 over 1.5 minus 1 squared. 1.5 minus 2 is going to be a negative. Anything squared is going to be a positive. So that tells me it's going to be a negative. So these are both going to go down to negative infinity. Okay? Same one, but now I'm going at 1 from the left. But I already learned, hey, this is an even vertical asymptote. One of them goes down, which means they're both going to go down. Now, you can check that by doing a sign line. If you plug 0 in, you're going to see that it's negative, so it's negative infinity. Or you can just do the shortcut of this is an even asymptote, so they're both going to go the same direction. Okay, number 5. This is going to be a vertical asymptote at x equals 2. It's going to be an odd vertical asymptote. And in fact, actually, did anyone catch my mistake? We can simplify this. Let's simplify this. As x goes to 2, I can factor the top, which means this is not an asymptote at all. This is a whole, which means this is like 1.2. Since it's a whole, I can just plug it in. So, there's that one. Let's see, did I do that right? Yep. Okay. In the next one, we'll do some more examples.